Hi, this is Paula J from Secure Academy. Welcome to another episode of Secure Hacks Weekly. As usual, we have some interesting subjects for you, and today I got with me Mike Jankowski-Lorek, our security specialist on security, databases, identity, and many more subjects. And today we have a very interesting subject because we're going to be talking about names.
Yes, today's topic is protect your name, how to secure your DNSs. Whenever we are talking about network communication, first thing is to resolve the name. So we need to have a way to ensure that the name that you are using in an application is translated to the IP address that is actually for this server. So we'll be talking about DNSSEC.
That sounds very interesting. Okay, so let's dive in.
Before we begin working with the DNSSEC, let me introduce our environment. We have a Windows 10 client machine, which IP address is 10.1.1.101, and it's set that it's using the DNS server under IP 10.1.1.1. This is our domain controller for the same domain that this is for the Windows 10, so it's secure.lab. And we have also on this domain controller the DNS server, which has the zone secure.lab. We also configured on that DNS server a forward lookup zone. We also configured on this DNS server a conditional forwarder for the domain raccoons.lab, and it's set it for the GW01 server with the IP address 10.1.1.254. On this server we have a DNS server that is responding to the raccoons.lab. We also have a attacker's machine, which is actually Kali Linux, and the IP address of it is 10.1.1.113. We will be using this machine to host our danger application that will be spoofed by using DNS poisoning, and we will actually use app spoofing to substitute the responses sent from gateway, so from this GW01 server, to the SDC for any request regarding raccoons.lab. So whenever the client computer will ask our DNS server for the www.raccoons.lab, Kali Linux machine will try to redirect the traffic by substituting the DNS queries, responses, to the Kali Linux IP address instead of going to the safe website, which is on the 10.1.1.1 server. So let's see it in an example. First of all, I will start the service on the Kali Linux machine and verify what is the IP address of this machine. It's 10.1.1.113. So let's move to the Windows 10 machine, and first of all let's clear anything that was previously used on this machine, clear the ipconfig and flash DNS. So now what I want to do is just simply to start the Internet Explorer. Let's pin it and go to HTTP 10.1.1.1. This is the safe website, and we have the second server, which is Kali Linux, with an unsafe web page. What I want to get is when I type HTTP www.raccoons.lab, want to get to the safe website. The attackers will try to spoof this and to get the responses redirecting to different server. Okay, just not to forget, let's clear the cache again. Okay, the cache is cleared. Let's close the browser so we are sure it's never cached there. And let's go to the SDC virtual machine. So it's our domain controller. On this domain controller, let's clear the cache and also clear the DNS cache. So I have this command here. It's clear DNS server cache. Of course, yes, I'm allowing for that. What else I can do is actually clear the cache on the DNS manager. So this is the same as clearing it through the PowerShell. I have here a conditional forwarder that is set to the IP address 10.1.1.254. So each request for raccoons.lab is going to this IP address to resolve it. So let's go to that server. Okay, let's see it. On that server, this is GW01, we have a forward lookup zone, which is raccoons.lab, and we have only one entry here for host A, that is www, which is pointing to the SDC on which we have the safe web page. Okay, so now let's see what we can do without DNSSEC applied to the servers. First of all, let me show you etc ethercap ether DNS. In the DNS configuration for the plugin for the ethercap, which is a very powerful tool, we will have entries for www.raccoons.lab, and we have record A and information that this is our IP address of actual Linux machine. So let's close it and let's start ethercap with graphic user interface. It will be easier to perform it. First of all, we need to sniff. It will be unified sniffing on the Internet 0. Next, let's see the hosts and let's scan for the hosts on the network. It's scanning. It will show me all the hosts that are available right now. So I have the target machine, which is SDC, and the target machine, which is gateway. I will perform up spoofing between those two virtual machines and perform man-in-the-middle attack based on this. So I selected the targets. Now on the man-in-the-middle attack, I'm using up poisoning, sniff remote connections. Okay, so it started to perform the attack, and now I want to use the plugins, and one of the built-in plugins is Dns Spoof. I just enable it. The last part is start sniffing. So whenever I start sniffing here, you will see that requests for www.raccoons.lab will be substituted with actual the IP address of the Linux machine. So let's switch to Windows 10 machine. And now let's try to resolve the names for the raccoons.lab. As you can see, this time it's already 10.1.1.113. So as you can imagine, if I open the Internet Explorer and go to the www.raccoons.lab, I will get unsafe web page. So basically the DNS spoofing was successful. Okay, what I can do next? I can enable the DNSSEC on the gateway. So on this computer, I can just simply make DNSSEC and sign the zone. This will generate the keys, and of course I can customize everything, but for the demo purpose I will just simply use default setting for signing the zone. This is very simple. It's creating KSK key for signing the zone. The algorithm will be RSA SHA-256 with 2 kilobits of key. So let's try to do this next. It's signing. When I refresh information here, it will actually, you see much more information. There are entries for RR signatures, for the DNS keys that are used for the encryption, for the signing actually of the zone, and we have also here NSEC3 parameters for signing, and for every entry that we have here, for example www, we have also a signature here that is with the information about this particular entry. So this is the signature in base64 form for www.raccoons.lab. Okay, let's see what if this is changing anything on our servers. So let's go to first to SDC01. Let's clear the cache. Okay, the cache was cleared. And let's now try to resolve the name for the raccoons.lab. Okay, still getting the information that the IP address was spoofed. Let's try to flush DNSs and let's try to do it again. This time I'm sending information that I'm able to consume the DNSSEC entries. In this case, I got nothing. Let's try to do this against the GW01 server. Okay, still nothing, because I'm substituting the older response from the server GW01 with the responses made by the Kali Linux. Let's see what will happen if I stop the spoofing. Okay, so let's go to the Kali Linux. Okay, stop sniffing. Let's try to do it again on SDC01. First, clear DNS server cache. Yes. Now let's try to do it. I didn't stop the man in the middle attack. Let's try to do it again. Man in the middle, stop man in the middle attack. Okay, stopping it. Yeah, stopped. Let's go back. This is my SDC, so let's flash this one, flash this one. Yes, and now let's try to do it again. Yeah, now I'm getting the correct answer. Let's try to see what will happen if I use with DNSSEC OK, the switch. Now I'm getting additional information about the signature for that entry. I can also ask it directly on that remote server, and I will get also the information about the signature on that server. So is it preventing me from getting the responses that are not valid? Actually, not yet. First, let's try to get the trust anchor for that zone. To get it, I will query the remote server. Okay. I will query the remote server for the DNS keys. These are the 4 keys that are used here for actually making a signatures. So I will add those keys, the record data, as a DNS server trust anchor for this zone. So now if I go to the trust points on my DNS, let's see, there's nothing. If I add right now those keys and refresh the trust points, I'm actually getting the entries for the DNS keys. So let's try and verify what will happen right now. Still, I do not get additional information without setting the DNSSEC. This is getting me also all the information. So let's now try to resolve the name on the server, on the actually Windows 10. So I will close this website. Come on, close it. Just simply flash DNS, and I will ask first for just raccoons.lab. It's getting the correct response. If I ask it on the gateway server and say that I want to get DNSSEC, I'm getting the signature. If I try to get it from my DNS server, local DNS server for this Windows 10 machine from the SDC01, I'm getting also the signature here. Let's try to get the signature for the zone that is not signed. There's nothing because secure.lab is not signed. Okay, so let's now try to again spoof the DNS responses from Kali Linux. Let me sign in. Okay, I'm starting again the app poisoning and again starting sniffing. So let's go to SDC. Let's clear the cache and let's clear the local ipconfig cache of the DNS. Let's try to do it. This time I'm getting information that the record server failure because I cannot actually verify the information with the signature that I have a trust anchor currently. Let's try to do this with DNSSEC. Still not possible. Let's try to do it directly on the gateway server. This time it's saying, okay, that was the response directly which I'm getting from the gateway server. It's not from the gateway, it's from the Kali Linux. So if I'm trying to ask for the response from gateway, it's allowing me to get the response. Let's see what will happen if I do this on the Windows 10 machine. Okay, so now I will try to request for raccoon.net again, and the response is actually exactly the same as on the server. So my DNS server is rejecting the response because it's not signed with the keys that I have in the trust anchor. So the only last part which I actually should perform is to enable NRPT policy on my servers. So I will stop again the DNS spoofing and stop man-in-the-middle attack and try to do it again on the Windows 10 machine, the requests. So, oops, I'm still getting information that's not correct one. Let's try to clear the cache. Let's verify. Okay, it's correct one. It's getting the signature. Let's go now to the Windows 10 machine. And now I can try to get this information again. Now it's correct one with the signature. Everything is okay. But usually we are just asking for using the DNS names without additional switch for getting the DNSSEC record. There is something called NRPT policy. So we can assign the domains for which we are enforcing the need to use the DNSSEC. Let's try to do this. Let me go to the SDC. So let's clear the cache, and right now I will create a group policy that will apply NRPT policy for this actual. Create a GPO, DNSSEC, pol NRPT. Okay, let's edit this policy. In the policies, in the Windows, in the computer of course configuration, I have a name resolution policy, and I will add it for the raccoons. Remember, never use a wildcard here. Raccoons.lab, enable, require, and or create policy, and also in the advanced global, let's apply it to both IPv4 and IPv6. Okay, and remember at the end, apply the policy. So now I can close it. Let's verify it's there. Detailed, settings. Yeah, NRPT policy is here, so I can close it. Now I can switch to Windows 10 machine and update. Wait until the computer policy is updated and verify NRPT policy. So every time I will be asking for raccoons.lab, it will enforce using the DNSSEC. So let's try it. And as you can see, without the DNSSEC switch, I'm enforcing to use the raccoons.lab. So what will happen if I lose a trust anchor on SDC 01? So let's try to remove the trust anchors for the raccoons.lab. Yes, let's see what's happening in the DNS in the DNS console. Refresh this one, and we have no trust anchor currently. So let's clear the cache. And let's go to Windows 10 machine. Let's see what will happen. Okay, ipconfig flash DNS. Now let's try to resolve this one. We are getting information that DNS error unsecure packet. Let's try to do this on SDC 01. On SDC 01, I'm getting the response without any problems because I'm not requesting for DNSSEC and I'm not validating it because there is no NRPT policy for the domain controller. So actually, right now, without providing the DNSSEC, I'm not asking for the DNSSEC. So let me get back the records. Otherwise, it will not be possible to get the responses on the Windows 10 machine because it's required to be signed with DNSSEC. I need to refresh. Okay, let's try to do it again. Oh, probably on the cache on the server. SDC. Okay, let's try to do it again. Just to be on the safe side, clear this one, and let's resolve. Yeah, this time everything is working perfectly. So now if I will see that it's not resolving properly because there is some DNS spoofing, it will not allow me to get to raccoons.lab website. Oh, it's caching from Internet Explorer. Of course, refresh it and then we get the secure website. So remember, if you want to protect your zones, always use DNSSEC for that. Otherwise, it is possible to spoof the DNS responses and it can redirect you to not the site or not the server that you are expecting.